This lesson will be force as a vector. So force we can have by pushing or by pulling an object. Force is acted upon an object. The unit of measurement for force is newtons. So let's say force, first force on a plane. If there was force acted, if there is no inclination, let's say this is the force we have. This force on a plane has two components, horizontal component and vertical component. This is horizontal component, and this one here is equal to this, therefore it is vertical component. If this is an angle theta, the horizontal component plus horizontal component plus the vertical component using triangle of law of vectors, it is the resultant, which is F. We call this resultant R. This is the resultant. Opposite to resultant, exactly with the same magnitude, is called equilibrant. Equilibrant has the same magnitude as F, but opposite direction. Therefore, resultant and equilibrant are in opposite directions. I can have a force from an object in an inclination. This is an object we have. So if I have this object here, there is gravitational force going down Okay, if this is an angle theta, this force has two components, which is vertical, which is called the normal. This is a vertical, which is the same as the vertical, or we call it the normal. And this is the horizontal force, horizontal component, FH. Okay, so this theta, this is theta, because we know this whole thing is 90 degrees. And these are, we can make a parallelogram here. So using this angle here, sine will be opposite of this one, which is horizontal component. Therefore, in horizontal component here is exactly opposite to the one we saw in the plane. Horizontal component will be, okay, that we didn't write it here. Horizontal component here is the force. The magnitude of this will be the force multiplied by cosine of theta, and the vertical will be the force multiplied by sine of theta. In here it will be the opposite. The horizontal one, which is this one here, which is this, we'll use sine, because sine theta is opposite to this one. Therefore, the force, our force is always Fg here, times horizontal component, which is opposite we said, which is sine theta. And then Fv, which is F normal, will be Fg times cosine of theta. So these are the two basic things here with forces. Another concept we should know is, in a triangle, if there are two forces, with the side of this triangle, let's say this side we have 5 newtons here, 6 newtons here. The third one, the longest one, if this is the longest one cannot be more than the sum of the two smaller ones. So if this is 13, let's say, this is not in equilibrium. Not in equilibrium. Because the longest side of a triangle cannot be more than the sum of the two smaller sides. Okay, so let's see an example of this. A mass of 12 kilograms is suspended from a ceiling by two cords that make angles of 35 degrees and 38 degrees. So find the tensions in each of the cords. Find the tensions on each of the cords. So let's see, first we do the position diagram. Let's draw first position diagram. What does position diagram mean? Position diagram means as you visualize it, as you see it, position diagram. The position diagram is, I have a ceiling here. This is a ceiling. Then there is a cord which is 35 degrees with this. Then there is another cord which is 48 degrees. So this is the gravitational force, which is Fg, and this is tension 1, this is tension 2. And we know the magnitude of the gravitational force is always 9.8. This is weight. Weight is always 9.8 times the mass. The mass is 12, which is 117.6 newtons. Okay, so now this is position diagram. Now we visualize this one in a vector diagram. Vector diagram. A vector diagram, we have to use vectors. So the first thing is parallel to T1. We go exactly parallel to T1. T1 makes 35 degrees with the ceiling. So we write 35 degrees. And then from this point here, we go parallel to T2, exactly the way it is on the position diagram. This is T2. So now T1 plus T2 as triangle of forces will be the resultant. This is the resultant, T1 plus T2. Or it is opposite of the gravitational force. They have the same magnitude, opposite direction, we said. Therefore, we know now this is our resultant R. So this angle is 48 degrees. So we'd like to find now T1 and T2. If I want to find T1, this is opposite, so I need this angle here. This angle, since this is 90 degrees, because it's a ceiling, 90 degrees, so this angle will be 42 degrees. Therefore, I say sine of 42 degrees over magnitude of T1 is equal to sine of 83, because we know R, I can use the angle, the whole angle here, 48 plus 85, 83 degrees over R. R we know is 117.6. Therefore, T1 will be 117.6 times sine of 42 over sine of 83 degrees, which is equal to 79.3 newtons. This is tension 1. From the same diagram, we can find tension 2. Tension 2 will be, I will use, if this is 35 degrees, this will be 55 degrees. So I say sine of 55 degrees over tension 2 is equal to sine 83 degrees over 117.6. Therefore, tension 2 will be 117.6 times sine of 55 divided by sine of 83 degrees, which is 97.1 newtons.